Welcome to AI for Local Impact, a podcast that explores the role of artificial intelligence in advancing development by highlighting work done through the AI for D program. The Artificial Intelligence for Development program, first established in 2020, is funded by Canada's International Development Research Centre and the UK's Foreign Commonwealth and Development Office. The program supports responsible AI ecosystems where experts in developing countries can create solutions to pressing development challenges while also mitigating risks through safe, inclusive, rights-based, and sustainable AI applications and policies. In this episode, we turn to Uganda, where the Makerere University Centre for Artificial Intelligence is positioning itself as a leading centre of excellence in responsible AI for development. The lab is driving research and innovation in critical areas such as health, agriculture, and natural language processing, while also training the next generation of AI researchers. I'm your host, Salam Abdullah, researcher at the Global Center on AI Governance. Joining me today is Dr. Joyce Nakatumba-Nabende, senior lecturer in the Department of Computer Science at Makerere University and head of the Makerere University Centre for AI. Her research spans machine learning, natural language processing, and responsible AI in health and agriculture. She's at the forefront of building Africa's capacity for AI research that addresses real-world challenges. So let's start with, why was this lab created?
Thank you. That's a good question. So the lab was created to provide a space where students in the Department of Computer Science could be able to do research in machine learning and AI for societal good. You see, our center is positioned at Makerere University, and we do offer artificial intelligence and machine learning, both at our bachelor's, master's, and PhD program. And so the lab offers a place where students can come in and practically learn how to build AI solutions. But it's not only for the students in computer science. Our lab is positioned to be multidisciplinary in nature, where we also have collaborations with different people from different disciplines and different colleges, for example, in health, for example, in agriculture, or even language, who are interested in building practical AI solutions for societal good.
That is wonderful. And what's the vision that guided this creation?
So the vision was to really bridge the gap in providing an end-to-end pathway in which we are able to build practical AI solutions that meet the different end user needs that we have in our community and specifically in Uganda.
So you did mention that you are working towards addressing particular needs in your community in Uganda. So what are these specific challenges that are in the country that your lab is hoping to address?
Yeah, thanks. That's a great question. And these challenges are very many. I bet as a lab we can't solve them all, but I'll just maybe mention one or two examples of the things that we've been working on that I think are very pertinent to me. One, of course, is the issue around language. As we all know, not just in Uganda, but even in Africa, we speak several African languages, right? And so one of the things that has been pertinent is trying to solve the problem of how to build AI solutions that can be able to address and speak the languages that the community understands. And the example that I can pull out here is, for example, if I look at a smallholder farmer is in their garden. They have, for example, realized that there's a new disease that they see that they don't know about. One of the things that they would do is, for example, go and seek advice from an agricultural expert. But they're in a remote village where there might not be internet connectivity or even mobile phone connectivity, and yet they need to find advice on what to do for the disease that they have found in their garden. So one of the ways that you could think about trying to solve this problem is, let me try and find maybe the farmer community leader who I can talk to, who can be able to reach out to an agricultural advisory officer in my community to help me come down to my field and then diagnose the disease that I see. But we have technology, and one of the things that we started out by doing is, how can we be able to first of all build, for example, computer vision models where a farmer, and even if it's not the farmer themselves, but the farmer leader who has a phone can have a model deployed on their mobile phone, and they can take it to a fellow farmer, take a picture of the crop or whatever it is. And then the model is able to give them a diagnosis and say, oh, maybe you have this particular disease of cassava. And that's like a very simple problem that can be solved with building computer vision technologies. But the issue is that when I see that I have a disease in my garden, what do I do as a smallholder farmer? I need advice. I need to, find remedies of avoiding the spread of disease in the garden because it could affect my yield for the entire season. So the farmer needs advice. As a farmer, you want advice in your local language because you might not necessarily understand English. And so that brings in the work that we've been doing around languages, trying to build out data sets for building and training these natural language and NLP, natural language processing and ASR models. But most importantly, can we be able to provide a particular or a good use case on top of these technologies that are being developed? And if I relate that back to the smallholder farmer, we've been able to build out automatic speech recognition models and agricultural advisory models, all powered by AI, that a smallholder farmer can take their mobile phone, they can be able to ask a question in a local language and receive back feedback that they can use for their disease problem that they had earlier, but providing this in local languages that they understand.
Mm-hmm.
Yeah.
That is very impressive because you're using natural language processing to apply it to a sector that is critical in your country.
Yes.
Can you share some of the lab's flagship projects across, you've mentioned agriculture, but health, climate, or other ways that you're applying language?
Yeah. So maybe language is just one. I think thinking about the flagship projects that we've been working on, I will still go back to agriculture, but this time instead of focusing on the farmer-facing solutions that we have developed, I will speak about the expert-facing solutions that we have developed. So we've been collaborating with the National Agricultural Research Organization, and this is the organization in Uganda that is mandated to carry out breeding of different varieties of crops. For example, we've worked with the team that's building out better varieties for cassava, better varieties for sweet potato. So if I look at these teams, if I, for example, take the cassava team, they're interested in looking at the different trials that they have planted to understand which trial can I best advance forward that is resistant to one of the diseases in Uganda, which is cassava brown streak disease. Mm-hmm. And so when they have the garden, they have planted all the cassava over maybe the season. They have so many varieties that they have harvested, and when they take out the cassava, they want to do the scoring to understand and say maybe this variety that I planted is more resistant to this disease that I am breeding for against another variety of cassava. Mm-hmm. So when they uproot the cassava, they slice it, and then they're able to do scoring. Mm-hmm. But we've realized that when they do scoring with the human experts, there is always bias, because I can, for example, score the disease as 3, yet someone else could score the disease as 4, and that can affect which varieties we can progress with as we go along with the trials. So one of the things that we built out for them is to do image processing based on computer vision, that you can just take a picture and then the model is able to give you a non-subjective score, but also doing this in a faster and more efficient manner, that you can just harvest your cassava, leave it out there, we can just come take the pictures and then have a layout of your garden with the scores that the model has been able to give. And this then helps the farmers to be able, the experts, to be able to progress really quickly in doing scoring of the harvest that they have done for their cassava breeding cycles. And that's really image phenotyping, and it's been a very helpful tool for them. Speaking about experts as well, as they are breeding, for example, for whitefly resistance. So whitefly is the pest that spreads the cassava brown streak disease. Mm-hmm. So what the farmers do is that they go out in the garden in the hot sun, they take the cassava leaves, they flip them over, and then they want to count how many whiteflies is affecting this cassava leaf. Mm-hmm. And they do that manually. So imagine you flip the leaf. By the time you flip the leaf, some of the whiteflies have flown off, but the whiteflies are white in color. So then you have to bend and manually count 1, 2, 3 until you get the number of whiteflies on the leaf. And we thought, no, that could be a very good computer vision problem. So when they do that, we take a picture, and when we take a picture, we have built different computer vision and segmentation models that are able to automatically segment the whitefly on the leaves and give you a count of how many whiteflies you have. It might not be 100% accurate, but it's much better than the expert bending in the field to do the counting. Now we have an interface for you where you can upload your data set or your image data, and the model is able to do the counting for you. So I just thought I would mention that, because sometimes when we think about agriculture, we always think about the smallholder farmers, but we also have the experts who are very interested in giving us better varieties of cassava or even sweet potato, for which AI and machine learning and computer vision are very helpful tools for them. So when we switch to the health domain, again, together with different colleagues that we have at Makerere, for example, from the Makoni Machine Learning Lab, that's a lab that we've collaborated with over the years. They do a lot of work in healthcare, and the work that they do is really around imaging, medical imaging. And we've had many students that we've supported and we've worked with, for example, who have looked at building computer vision models for lung disease detection. We've looked at work around breast cancer detection, cervical cancer prediction, or detection as well, and prediction, and we think this is very important work because of the way it overlays with the radiologists who are in charge of doing the screening in the different communities, but also providing capacity for the students who are benefiting as part of this collaboration between the labs that we have at Makerere and the health experts that we have in Uganda. So I think I'll pause there on some of the examples. Of course, I could say a lot more. Maybe I should, but I will pause there for any other questions.
No, that is very impressive, because you're working in critical sectors to make sure that it's more efficient and accurate for experts, as well as kind of the front facing for farmers, or whether it be for healthcare patients as well. And what would happen if you or your team weren't necessarily working on such critical projects? And so this would help us understand why your lab, and why now?
Perfect. That's a good question. So one of the things that would happen is that we would have AI solutions that are developed outside the continent being brought into the continent to solve our own problems. And I feel like that's a critical gap, right? Because if you want something to work in your continent, in your context, then you have to develop it from the ground up. You understand the context, you understand the problem that is happening, you build your data sets around this problem, and then you're able to build out the AI models. So if we weren't doing this work, yes, I think people would still adopt AI, but what kind of AI would they adopt? Would it be AI that's context relevant for their problems that they're solving? Would it be AI that reflects whose data is it reflecting? Those are the types of problems that I think keep us at night, to make sure that the AI solutions that are being developed reflect our data, they reflect our context, they're able to speak to our problems. We have co-designed them with our communities, because we think that those are key and important areas as we try to achieve responsible AI in the development of our AI solutions.
So you've mentioned a lot of these innovations that you're working on, and I'm wondering, how are you combining these innovations with the training and capacity building that your lab also does?
Yeah, that's a very good question. So I kind of see this as intertwined, right? So when we have students who come into the lab and they're like, oh, I want to learn about machine learning and AI. So the first thing we tell them, oh, that's okay. That's a very good, challenge that we can work together to solve you learning. So we definitely start out by saying, let's just look at the data, because with machine learning and AI, the foundation is the data. So we start by giving them a data set that they can work with, or if we have data collection in the field, we will carry them along so that they experience and know where this data is coming from. Like if we have a voice collection drive in the community, we'll go along with them. And usually people come in when they're doing like internship, like they are maybe second year or third year internship, and we find that as a very good place to build capacity at that point in time as they're learning. So before we even tell you, go and start building a model, do you even understand the data? So we practically take them through, we practically walk them through the whole point of understanding how to build data sets, understanding how to build the models, but dealing with the data sets that we have collected and worked with. Because when we started out as a lab, we were not in a place where we are now. We had to start from scratch. We had no data sets. We had all that problem of there are no data sets, as we've been crying for many years. But now I think with the work that we have done, that we have built a portfolio of data that people can actually work with, and these data sets are openly available. So if I take it back to the capacity building that we are doing, as we are teaching our courses, we're doing them in a more practical manner, because we have this data that the students can work with. We have these projects that the students can be attached to learn as they go along. And I know that there are many people who have gone through the lab and are in other places right now, but they have gone through the training, the capacity building that we've gone through. And the training is not even just around the machine learning and AI models, even just training how to write a research paper. I find that as something that is very critical. Writing, expressing yourself, ability for students to speak up, to present, because we also have presentations where people are given opportunity to present their work and feedback is given. So I feel like it's a multidisciplinary way of training out people, that it's from the model development, the data set, but also learning how to write, which I think is a critical part of us that we need to go through as scientists.
So a lot of the students are essentially learning by doing.
Yes.
And also not learning just the technical skills, but the ways in which they can amplify their work.
Yeah, I think those are very good words to use around amplifying the work, making sure that your work is out there, giving you opportunity, for example, to go for conferences like Data Science Africa, Deep Learning in Daba, Black in AI. We feel like those are very good opportunities that people can be exposed out there. One, to understand the kind of research that's going on, but to also get feedback on the kind of work that they do, not just from us as the Makerere or Ugandan community, but even outside the continent.
Wonderful.
Yeah.
And what does being a multidisciplinary lab look like? Because you did mention that being a critical part of your lab.
Yeah, perfect. That's a very good question. So by multidisciplinary, according to us, I think it means that we're able to have one, collaboration with different fields. So we come out from a computing background. But the way we want to do AI is we want to make sure that AI is solving a societal need. It's speaking to a particular need. These needs are given to us by domain experts. The domain experts could be people in health, if it's a radiologist, for example. It could be people in agriculture, or if we're looking at an agricultural expert. And if it could even be a smallholder farmer, it could be someone in education if we wanted to, for example, build AI models to help education or to create different learning pathways for students. So it could be any particular person coming in that's not necessarily from the computing background, but they have a problem that they think AI and machine learning could solve. So for me, that feels like it's a multidisciplinary, that you're able to work with people in the College of Health Sciences who are not computing people, but you're able to work with them both to do that training, because recently we just supported the Department of Microbiology, where they were starting up they were actually revising their Masters of Science in Bioinformatics and added a data science track, and we supported them to do that and to incorporate data science courses, particularly for health. So there's also that from the teaching perspective, that we're able to strengthen different programs where data science could be applied. But if I think about it in terms of the research, just the collaboration that we've had with people from the College of Agriculture, from the College of Health Sciences, the people in the National Agricultural Research Organization, people at the Uganda Cancer Institute, or even people from Ekuri, which is an imaging center in Kampala. I see that as multidisciplinary, that you have a need that is coming in from the community, and then you're working collaboratively to solve it using AI and machine learning technologies.
And I can imagine that working across different disciplines and domains and directly with communities comes with a very unique experience. So could you please just describe what it has been like working beyond the computer science community?
Very good question. So I think one of the things that we have learned, like looking at the work in I guess every work, but I'll give an example. For example, in the healthcare space, is learning how to interpret X-rays. If you look at an X-ray as a computer scientist, you do not know what you're doing. But if you look, for example, at an X-ray, and you have to build a model that's able to do and distinguish and say this is a healthy lung or this is a lung that has disease, you don't just throw that into the model and the model is supposed to figure out what you're trying to do. You need to understand what it is. You need to look at the X-ray image. You need to annotate it. You need to also understand and know that this is where the particular disease is in my X-ray before I actually start to build my models. And so I think for many of us, and even our students, it's a learning process to learn and step into that particular discipline to understand what it means. If for example, I give the example of a sweet potato and it's agriculture. So for sweet potato varieties, I don't know how many people eat sweet potato here, but for us who eat sweet potatoes, when you put a sweet potato in your mouth, you can actually tell that this sweet potato is soft. I don't like it. This sweet potato is more crumbly. I think I prefer this sweet potato. Now, imagine you have to build machine learning models that are able to differentiate a soft sweet potato from a more crumbly sweet potato without having to eat it, right? That's how hard it can get. But that helped us to just look at an image, and with the help of experts, use computer vision to understand what it's like to have a more mealy sweet potato compared to a less mealy sweet potato. We are not agriculture experts, but we step into that domain. And I think what's interesting for us is to learn what those people do on a daily basis, the experts do on a daily basis, and then interface that with technology and see how to build our models to speak to their world. So it's like two worlds meeting as we do this collaboration.
Yes, and it's really impressive to see that it's not just your expertise, but also your human capabilities that are stepping into this space and trying to have a reciprocal kind of process of co-learning between your field and the other fields that you're working on as well.
Absolutely.
And how does your lab contribute to the wider African AI ecosystem? Because so far we've talked about its impact in Uganda and specific communities in Uganda, but how does it go beyond your country and to the broader African AI ecosystem?
That's a good question. I think from the trainings that we do, we are contributing really by bringing out AI experts that's students that are knowledgeable, that have been trained in AI, but also thinking about the different AI communities around. If I think about language, Masakani, for example, there are many projects where we have collaborated together. We've had data sets created in our languages that contribute to the bigger ecosystem in the NLP space. For example, data sets around named entity recognition. We've been able to, of course, contribute to, for example, Data Science Africa, so where I am a board member of Data Science Africa, and particularly just sitting there and planning for the different trainings that we have rotating around the continent and building the next data scientists, I think is a privilege for me to be part of, to see the value of where someone says, oh, I actually attended this Data Science Africa 2 years ago, and now I have gotten a master's scholarship in a university in Germany. That's amazing, right? That if they weren't given the opportunity to get into that space of being trained, that it wouldn't have opened up the world for them to maybe get a scholarship to do a master's or get a fellowship to go to another lab. And definitely with the AI4D labs, there's the collaboration that we have between the labs, that we're able to co-supervise students from the different labs together. I feel like that's also a great way that we're not just focusing on our country, but we are focusing to building out this collaboration between us as African scientists.
And it's great to hear that the labs aren't working in silos, but are essentially a network of experts working in different spaces, but can share different experiences and resources as well. And this might be a tough one, but in one sentence.
Oh, that's a tough one.
Why must Africa lead its own AI research agenda?
That's a tough one. So Africa should lead its own research agenda because Africa understands its problems. Africa understands its context, and Africa has the capacity to be able to contribute to the AI space. It's more than a sentence, but well.
Thank you so much, Joyce, for joining me today.
Yeah.
You've been listening to AI for Local Impact. This podcast is brought to you by the Global Center on AI Governance for the AI4D program. To learn more about this project and the larger program, please visit ai4d.ai. Be sure to subscribe to this podcast, share this episode, and join us next time as we continue to explore how AI is shaping development across the Global South.